Right. Prop 25 says, if two triangles have the two sides equal to two sides respectively, but have the base greater than the base, they will also have the one of the angles contained by the equal straight lines greater than the other. So probably after Prop 24, this feels pretty similar, and you probably see what it's saying already. But the idea is that if you have two triangles where, say, AB is equal to DE, AC is equal to DF, and BC, the base, is greater than EF, then the angle BAC is going to be greater than the angle EDF. So it's similar to Prop 24 because Prop 24 had the same setup with these two lines being the same, but Prop 24 said, well, assume that this angle is larger. So this is like the other direction of Prop 24. So they kind of work together to create, 24 and 25 create something of a biconditional, which is basically that if AB equals DE and AC equals DF, then BC is greater than EF if and only if angle BAC is greater than angle EDF. So yeah, they kind of work together. They're similar, but they are saying something slightly different. All right. And since they are so similar, you actually can go through and you can prove Prop 25 in like a very symmetric way to how we proved Prop 24. And I did that, so I'll kind of show that to you at the end of the video, just flash it across. But that method of proof is longer and kind of less elegant than what Euclid does. Euclid uses Prop 24, and he basically does this as like a pigeonhole contradiction argument. So let's just jump straight into it and see what he did. Proof. So again, I'll write out what we're given. So we're given that AB equals DE. We're given that AC equals DF. And we are also given that BC is greater than EF. And we want to prove that angle A, angle BAC, is larger than angle EDF. And Euclid does it, like I said, he does it by contradiction. So he says, suppose it's not. So I'll do this. I'll write, this is a little shout out to one of my old professors, Dr. John Carter, who kind of got me in the habit of, and read, instead of writing suppose, writing suppose. And it kind of stuck for me. He did a lot of things that stuck for me. All right, so suppose it's not the case. So suppose that angle BAC is not greater than angle EDF. All right. Well, if angle BAC is not greater than EDF, then there are exactly two possibilities. Case 1, angle BAC equals angle EDF. Case 2, angle EDF is greater than angle BAC. So we have two cases. Case 1. Then, well, maybe angle BAC is equal to angle EDF. All right. Well, if that's the case, then notice what we have. Then we have that AB equals DE, we have AC equals DF, and the angles in between them are the same. Side angle side. So if that's the case, then by proposition 4, we must also have that BC equals EF. Which is a contradiction. Because we're explicitly given that BC is greater than EF. So this can't be the case. So case 1, no, can't be the case. Case 1 leads to a contradiction. All right, let's check out case 2. So case 2 would be that angle BAC is less than angle EDF. All right. Well, if that's the case, then we just proved a proposition. Prop 24 says something about that case, the case where AB equals DE, AC equals DF, and angle EDF is greater than angle BAC. Well, if that's the case, Prop 24 told us then that EF must be greater than BC. So by Prop 24, it would follow that EF, or maybe I'll write it this way to stay consistent, BC is less than EF, which is, again, I'll put a contradiction this time. So it's a contradiction again. So we pigeonholed it. The only way that this can be possible, this setup can be possible, is if angle BAC is greater than angle EDF. So it must be the case that, right, yep, angle BAC is greater than angle EDF. Yep, and that's it. Right? Quick, clever, that's, yeah, that's nice and fast compared to what we had to do for Prop 24. Prop 24 involved a lot more. And you can prove this one. You can prove 25 in the same spirit as how we proved 24. I'll just kind of flash on the screen here how I did that proof. So it's this piece with the curly brace. So, and it's shorthanded. I just kind of shorthanded it just to see if it was possible. And yeah, it seems to be possible. So, but it's a lot more steps. There's a lot more justification. This one is just nice and quick and straight to the point. So definitely a superior proof, at least if you're willing to accept proofs by contradiction, which some people, there is some contention around it. Generally, direct proofs are considered superior, but yeah, in general, contradictions are also treated just as logically correct and logically valid as a direct proof. So this one works, and it's nice and quick and elegant, and it used two propositions. It's fast. So QED. Right. Therefore, etc.